So we've already talked about similar polygons, and if all of the angles are congruent and their sides are proportional, then that's how we know they're similar. So in this video, I'm going to talk about shortcuts for triangles specifically. So the first one, and some of these will be on your proof cards, so be on the lookout for them. The first one is called the angle-angle similarity postulate, and you can abbreviate that by doing AA, and to show similarity, just do that little squiggle tilde thing. All right, so if we know that two angles of one triangle are congruent to two angles of the other, then the two triangles are similar. So what's special and unique about triangles is that if all of the angles are congruent, then those sides have to be proportional. All right, and we know that that third angle would be congruent by third angle theorem. So this kind of incorporates that third angle theorem. You don't need it. And this is another way of writing it with the diagram there. So if you know those two angles, JKL and XYZ are congruent, and then KJL and YXZ are congruent, then those two triangles, and again, pay attention to the order that you write these angles. So if I say triangle JKL, then I'm doing J, then K, then L. So I have to do double, single, triple again, X, Y, Z. So just be careful with that when you write your not congruent statement, your similarity statements. All right, so in this one, we're given AB is parallel to CD. Remember, parallel lines should tell us angles. So I know here's my Z shape, my alternate interior angle. So C is congruent to B, and then A is congruent to D. And then, of course, we would also know that this third angle is congruent, or they're vertical angles as well. So we know that those triangles are similar. Triangle ABE would be similar to triangle, let's see, that would be DCE. Okay, it's good to know what matches up with what. But then they say, let's use that. So now that we know they're similar, then we know that their sides are proportional. So we're going to use that. We know AB is 5, AE is 4x, CD is 10, and ED is x plus 14. We have to find AE and DE. So we have to solve for x. So AE, if I put that over, so AE, if I put that over DE, X, or yeah, I'll just put DE for now, then that should be proportional to my AB, which was 5, and that's going to be corresponding with the CD, which is 10. So if I fill in those pieces, then I would say 4x over x plus 14 should be equal to 5 over 10. Okay, so we can cross and multiply. So that's 40x equals, make sure to distribute that 5 to that. So 5x plus 70. Okay, so we're okay with that. And then subtract your 5x. And then we're getting x equals 2. So remember, what they're asking us to find is AE, so plug that back in. So if I plug in 2 here, I'm going to get AE equals 8. If I plug in 2 here, I'm going to get DE equals 16. Okay, so that's how we can use similar triangles to help us find more information. We also have some more shortcuts, and one of them is called side-side-side similarity. Now, just so we don't get this confused with the congruence one, I do want you to put SSS similarity. Okay, if you just put SSS, I'm going to think you're talking about congruent triangles. All right, so basically, if we know that all of the sides are proportional, then we know those triangles are congruent. Then all of those angles then have to be equal. All right, so let's use that here. So which of the following triangles are similar? So we're going to compare the sides. All right, so if I look at the smallest, okay, that's the smallest here, that's the smallest there. So 4 over 6 We're going to see if that's equal to the medium over the medium, 8 over 12. And we're going to see if that's the same as the largest over the largest. Okay, so notice all of my numerators are from this left triangle, all the denominators are from the right triangle. And I just went medium, small, medium, big. All right, so if I reduce all of these, 4, 6, that reduces to 2/3. No. This one, if we reduce that, we get 2/3 again. And then, of course, 10/15 reduces to 2/3. So these are all equal. So those two triangles are similar. So triangle RSQ is similar to triangle. Let's see, RSQ, that would be small, big, then medium. So that would be VWT. Okay, be careful with that. And then so if we do the same thing with the right two triangles, if I do small, this one's the smallest, this one's the smallest, so I can already tell that that's not going to be the same. And then medium and medium. Okay, so we can already tell that that's not true. So those right two triangles, the right one and the middle one, are not similar. We can also try the furthest left and the furthest right. So that would be 6 over 4. So 6 over 4, is that the same as 10 over 8? And then largest and largest, 12 over 10. So again, if we reduce, that'll be, I just did it backwards, didn't I? So that'll be 3 over 2. This will be 5/4. So no, that's not going to work, is it? Okay, so those ones that we said in the beginning are the only two triangles that are similar here. And that's using side-side-side similarity. All right, then we have the side-angle-side similarity theorem. It's very similar to the side-angle-side congruence theorem. So if I have an angle that's congruent, just one angle this time, but then I have the other two sides that touch that angle, if those two sides are not congruent, but they're proportional, then I know those triangles are similar. Okay, so for example, we could do this proof. If we're given DF is 15, MN is 12, DM is 2, and then DR is 10. All right, so keep in mind that we're really talking about this big triangle and then this smaller triangle. Okay, we're trying to show that DFR is similar to MNR. Okay, well, let's figure out why that would be true. Do they have any angles that are congruent? Well, we do have this angle that's marked congruent there. And then we do have the two sides that it touches. So I have this one is, this whole side is 12, right? And then the smaller triangle is just 10. So I'm going to put 12 over 10. And we're going to see if that's the same as this other side. So I'm going to have 15 as the long side. And then 12 right here is that side. So if I reduce that, this is going to give me 1.2. This is going to give me 1.25. Back up. I misread the diagram. So this is not 10 here, the whole thing is 10. So that's why I was confused. Otherwise, we were getting that they were not proportional, and then they would not be similar. So that whole side is 10. Okay, there we go. Which would mean that just the small part is, if this is 2, then this would have to be 8. Okay, so now let's reset up those proportions. So I'm going to have 15 over 12. We know that's right. And then big is 10 over the 8. So there we go. So now if I do 15 divided by 12, that's 1.25. And then 10 divided by 8 is also 1.25. Okay, so we know that those are proportional then, and we have those right angles from the diagram. So then we can prove that by SAS, similarity. So in our proof, we're going to write our given. I'm also going to put that angle, they didn't say it in the given, but it's in the diagram. So angle RDF, that big right angle, and RMN are right angles, because that was given in our diagram as well. So if you're confused on how to write that up, you just say it's given from the diagram. All right, so that means then that angle RDF is congruent to angle RMN, and that's because all right angles are congruent. That's the theorem. And then we can say that DF so I want to make sure I write it correctly. DF over MN equals, what would that be? DR over MR. And you can just say definition of proportion. Okay, because we did the math, or you could do the math right there. And then from there we can say triangle DFR is similar to triangle MNR. And that's by SAS similarity. All right, so there's a proof. And that's what we're going to be using for our triangle. So that's about the extent of our proofs. So we've got Angleangle, SAS, and SSS.